So, hello students, how are you? So, today we are launching our new course, free course. So, this course will be covering the basics of digital electronics. Only the basics we will discuss, whatever is important for the interview. It is not a detailed course, but basics of digital electronics will be covered entirely in this course. So, it will be available on the VLSI for all community app as well as on YouTube channel playlist. So from here you can download our VLSI for all app. It is available on the Play Store as well as on App Store. So you can download and you will get all the free courses available in this folder, first folder, right? So let us introduce our new faculty, Abhishek sir. Hello sir.
Hello sir.
So he will be teaching you the basics of digital electronics. So he will be starting with basics of logic gates. Yeah. Okay. So yeah. So you can continue. So yeah.
Okay.
Yeah. Okay, sir. Thank you.
So hello everyone. So today we'll be starting with our new topic in the digital design system, that is logic gates. So in this part we will be covering the basics of the logic gates, or we can say I will be telling you about the logic gates. Fine. So now what are logic gates in the digital design system? So logic gates are the basic building blocks of any digital system. Fine. Just like if we are building or constructing any building or something or any house, then what happens? The basic building block of that house or that building is brick. In the similar way, logic gates are the basic building block of any digital design system. Fine. So first we'll be looking what are logic gates. Fine. So as I have told you earlier, that logic gates are the basic building block of any digital system. Fine. So logic gates are the basic building block of any digital system. What these logic gates do? These logic gates basically perform digital logic functions that are fundamental to the digital circuits. Fine. In logic gates, what happens? There are basically two or more than two inputs available, and only one output is obtained in the logic gates. Fine. So in logic gates, two or more inputs are available and only one output is obtained. Fine. And logic gates can be broadly divided into three categories. So what are these three categories? So these three categories are basic gates, universal gates, and the special gates. Fine. So these are the three categories in which these logic gates can be broadly divided into. Fine. So now, next, coming to the types of the logic gates. Fine. So what are the types of the logic gates? So basically there are three types of the logic gates that I have told you just now, and those are you can say in the basic gate category, what we have AND gate, OR gate, and NOT gate. Fine. And in the universal gate category, what we have NAND gate and NOR gate as the universal gates. Next, coming to the special purpose gates. So what are the special purpose gates? Special purpose gates are the XOR gate and XNOR gate. So fine. So these are the basic types of the gates in which we can describe or categorize categorize different types of gates available in the digital logic design. Now, coming to the next thing that I will be telling you, that what is a truth table. So whenever we are studying about logic gates, we need to draw the truth table to understand the functionality of that particular logic gate. So with the help of the logic gate, we can easily understand the functionality of that particular logic gate. Fine. So what is a truth table? So first I will be telling you about what is a truth table. So truth table is basically a table which contains all the possible inputs combination along with their corresponding output. Fine. So it will be containing all the possible input combinations along with their corresponding outputs. Fine. So if there is one input available, fine. So we'll be checking that हमारे पास कितने total possible combinations available हैं. So for one input we'll be having 2 to the power 1, that will give you two combinations. Fine. And if we are having two inputs, so what will happen? Then 2 to the power 2, that will give total 4 combinations. Fine. And if we are having three inputs, then we'll be having 2 to the power 3, that is total 8 combinations available in our truth table. Fine. So in general we can say that if we are having n inputs, if we are having n inputs, so we'll be having 2 to the power n combinations. Fine. So if we are having n inputs, if we are having just a second, if we are having n inputs, then what we will have? We will have 2 to the power n combinations possible. 2 to the power n combinations. Fine. So for n inputs, we will be having 2 to the power n combinations. Right. Now, so this is all about the basic of the truth table. Now next, coming to the basic logic gate, and first we will cover with the AND gate. So first I will be telling you about the 2 input AND gate. First what I will be telling you about 2 input AND gate. So for the 2 input AND gate, this is the basic symbol, or you can say this is the basic symbol D, and here 2 inputs are given, A and B. You can see easily 2 inputs A and B are present, and we are getting Y as our output. Fine. So this is the basic symbol of the AND gate. Here 2 inputs are present, A and B, and we are getting Y as our output. Okay, and we are getting Y as our output. Fine. Now next, coming to the expression. So expression is Y is equals to A dot B. Fine. This is the basic expression of the AND gate. Here what we have taken? We have taken 2 inputs. So for 2 inputs, total number of possible combinations, how many we will get? We will get 2 to the power 2. That means total 4 combinations. Total 4 combinations will be getting in this AND gate. So here we can see total 4 combinations: 0 0, 0 1, 1 0, and 1 1. So these are 2 inputs. Fine. And now this is the output. Fine. So what is the function of this AND gate? So let me tell you what is the function of this AND gate. The function of this AND gate is if any of the input is 0. Fine. If any of the input is 0, then what will happen? It will give 0 as the output. You can see here A and B, both the inputs are 0. So we are getting 0 as our output. Here A is 0, so we are getting 0 as our output. Fine. Let me change the color. Yes. So here this part is 0. So we means B input is 0. So we are getting Y 0 as the output. In the last case, both the inputs are 1. Then only we are getting the output as 1. So and for this AND gate, disable input for AND gate is 0. This I have mentioned it here, that disable input for AND gate is 0. What does this mean? Disable input for AND gate is 0. What does this mean? This simply means that if on a AND gate, if any of the input is 0, whatsoever input we apply on the other gate, or on the whatever other inputs, whatsoever other input we will apply, it will always give the output as 0. So how this happens, I will tell you. Fine. How this is happening? So one of the input is 0. Fine. I am taking A. For A there will be 0 and 1 available, and for 0 it would be 0 and 0. Fine. So now what we have understood in the AND gate, if any of the input is 0, it will give the output as 0. Here this is 0, this is 0, so output will be 0. Here this is 0, so output will be 0. So for the AND gate, what is happening? If any of the input is 0, it will give the output as 0, and for the AND gate, 0 acts as a disable input for the AND gate. So in combination with 0, if we are applying A or any other input, if we are applying any other input, it will always give the output as 0. Fine. So this is the basic of the AND gate. Fine. Now next, coming to the 3 input AND gate. So here in this case, 3 input AND gate is available. Symbol remains the same. You know. And what is happening? Here three inputs are given A, B, and C. Three inputs are given A, B, and C, and we are getting the output Y. Fine. And now the expression will become. Now what the expression will become? It will become Y is equals to A dot B dot C. This is the final expression of three input AND gate. Fine. Now here we are having three inputs. So how many total possible combinations will be available? Those will be 2 to the power 3. That is equals to 8 combinations. Fine. So here we will be getting total 8 combinations. Fine. Here we will be getting total 8 combinations. So in this table, A, B, and C are the three inputs, and we are getting total 8 combinations. One combination, 2, 3, 4, 5, 6, 7, and 8. Okay? Total 8 combinations are present. And as I have told you earlier, that if any of the input is 0, if any of the input is 0 in the AND gate, then what happens? It will give the output as 0. Fine. So here you can see, if here in the first case all the three inputs are 0, here in the first case all the three inputs are 0. So what we are getting? We are getting 0 as our output. Fine. So here in our first case all the three inputs are 0, so we are getting 0 as our output. Here in this case 2 are 0, so we are getting 0 as our output. Similarly, in the other scenarios, you can see here also minimum 1 0, minimum 1 0, minimum 1 0, and if means in all these cases at least one of the input is 0, that is why we are getting the output as 0. In the last case, what is happening? All the inputs are 1, so we are getting the output as 1 here. Fine. So we are getting the output as 1 here. Fine. Now coming to the next. So here I have taken the example. So let me tell you what is happening. As I have told you till only about the AND gate. So this is the basic example here. Two inputs are available, A and B. So output would be A dot B, and from here the output would be C dot D. Now let us suppose this is gate 1. Let us suppose this is gate 2 and this is gate 3. When the output from the gate 1 is passed when the output from the gate 1 is passed as an input to gate 3 and the output from the gate 2 is passed as an input to gate 3, then what is happening? We will get the final result this. Now here what it will do? It will do AND of these two. So what we will get? We will get Y is equals to A dot B from here and C dot D from this part. Fine. So this is the basic example of the AND gate. Now, next coming to the OR gate. Fine. So this is the basic symbol of the OR gate. This is the basic symbol of the OR gate. Just a second. Just a second. Okay. So this is the basic symbol of the OR gate. Fine. This is the basic symbol of the OR gate. Here two inputs are present, A and B, and Y is the output. Okay. So what this gate is doing, and the expression for this gate is A plus B. Expression for this gate is A plus B. So what is the basic function of this OR gate? The basic function of this OR gate is, if any of the input is 1, then it will give 1 as our output. Fine. So this is the basic functionality. You can see here, if any of the input is 1, means here B is 1, so we are getting Y output as 1. Here A is 1, so we are getting Y output as 1. Here both the inputs are 1, so we are getting definitely what we will get? We will get Y means that is the output as 1. Only in the first case here, when both the inputs are 0, then we will be getting the output as 0. Fine. So this is the basics of OR gate. Fine. And now one more important thing, that as I have told you in the AND gate also, that there is for the AND gate disable input is 0. Now for OR gate, disable input for OR gate is 1. Fine. Disable input for OR gate is 1. Okay. So how this is happening, I will explain you. It means if we have taken any OR gate just like this is the Y output and there are two inputs, and I have told you that disable input for the OR gate is 1. So if on any of the input I am giving 1 and I am taking any other input on the other terminal. Fine. Now let us draw the truth table for this. So for A, there would be two combinations, 0 and 1, and for 1, obviously it would be 1. Just a second. And for 1, obviously it would be 1 and 1. Okay. And what output we will get? So what is the basic functionality of the OR gate? If any of the input is 0, it will give the output as 1. Here this is 1, so we will get the output as 1. Here both the inputs are 1, so definitely we will get the output as 1. So in OR gate, what is happening? If any of the input is 1, we will always get the output as 1. So the disable input for the OR gate is 1. Okay. So this was the basic two input OR gate. Now next, coming to the OR gate for the three inputs. Symbol remains the same. Symbol remains the same. Fine. Symbol remains the same. Now here, instead of two inputs, three inputs are given. That are A, B, and C, and we are getting Y as our output. Now the expression would become Y is equals to A plus B plus C. Fine. So this would be the expression for a three input OR gate. Now here three inputs are available. So as I have told you earlier also, if three inputs are available, so 2 to the power 3, that means total 8 combinations. Total 8 combinations are available. Okay, so in the truth table, we have taken total 8 combinations as per the three inputs. Fine. So these 8 combinations are 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so total 8 combinations are present. Fine. Now what will happen, as we have learned just now, that in the OR gate, if any of the input is 1, what we will get? We will get the output as 1. So in this case, only in the first case, all the inputs are 0. All the inputs are 0. So we are getting the output as 0. And in rest all the other cases, at least any one of the input is 1. So we are always getting output as 1 in rest all other cases. Fine. So this is the basic functionality of the OR gate. If any of the input is 1, it will give the output as 1. Okay. You can easily check the truth table. Fine. Now coming to the basic example of the OR gate. So in this basic example, this is just similar to the previous example that I had taken, but there it was I had taken with the AND gate. Now I am explaining it with the help of OR gate. Fine. So what will happen? Let us suppose this is gate 1. Okay. This is gate 2, and this is gate 3. Fine. So in gate 1, we are providing two inputs A and B. So what we will get? A plus B. Here we are giving two inputs C and D. So what we will get? We will get C plus D. Now in gate 3, output from the gate 1 is coming, and output from the gate 2 is also coming. Okay. So what will be the result of this? The result will be A plus B. This is the input, A plus B, plus of C plus D, plus of C plus D. Okay. So this would be the final output that we will get here. Okay. So you can see this is the final output we are getting here. Y is equals to A plus B plus C plus D. Okay. So this is the basic example of the OR gate. Fine. Now next I have taken the other two examples with the help of a combination of the OR gate and the AND gate. These two gates I have explained you till now. Fine. So now I will be telling you what is happening in these examples. Fine. So in this first example, two inputs A and B are present. So what we will get here, as this is the OR gate, so what we will get? A plus B. Now here the inputs are C and D. So what we will get? We will get C plus D. Now these two inputs are passed through a AND gate. Now what is the basic functionality of the AND gate? It will means it will take the inputs and provide the output as per the logic functionality of the AND gate, right? So what expression we would get here? Y is equals to A plus B dot operator C plus D. Fine. So this will be the output, and we are getting this output here. Fine. So this would be this would be the output of this particular circuit. Now next coming to this circuit. Fine. So here two inputs A and B are taken. So here what we will get? We will get A dot B. Now here C and D are the two inputs. So what we will get? We will get C dot D. Fine. Now what is happening? These two are passed as an input to the OR gate. So what we will get here as the output? We will get Y is equals to A dot B first input ORed with second input C dot D. Fine. So this is the final output that we are getting here, right? Now these two expressions that we have got, Y here and Y here, these are also known as, this expression is known as POS form or product of sum form. How we can say that? This is known as product of sum form. This is the product operator, you can say, and these are the product of two sums. Fine. So this is in the form of POS. Okay. Now this expression is in the form of the SOP form or sum of products. Fine. So here what is happening? This is one product, this is another product, and the sum of these two products are being taken into consideration. So this is the SOP form or the sum of products form. Fine. And further about this product of sum and the sum of products form, or you can say POS or the SOP form, I will be telling you in the further upcoming classes or in the further upcoming lectures. Fine. Now coming to the NOT gate. Okay. So in the initial slides, or you can say in the starting of the lecture, I had told you that in the logic gates there are two or more than two inputs. Fine. But in the NOT case, this is the exception. You can say here only one input is present, here only one input is present, and we are getting Y as the output. Fine. This is the basic symbol, a triangle with a dot. Fine. This is the basic symbol, and what this gate does, this basically inverts the thing, or we can call this gate as inverter also. NOT gate or inverter gate, or we can say inverter gate. Fine. Because what this NOT gate does, this basically inverts the whatever the input is given to this NOT gate. Fine. Now coming to the truth table, here only one input is present, so 2 to the power 1, that is total. Two combinations would be available. Total two combinations would be available. Fine. 0 and 1. Fine. So what this gate does, this basically inverts whatever the input is applied to it. Whenever 0 is applied, it will convert into 1. And whenever 1 is applied, it will convert it into 0. Okay. So this is the basic functionality of the NOT gate. Fine. NOT gate is very simple. So I hope that till now you must have understood all the three basic gates that were AND, OR and NOT. Now this is the basic example. Now here what you have to do, you have to just write down the expression. Fine. You have to just write down the expression in this case. So you can pause this video for 2-3 seconds and you can easily write down the expression here. Now I am telling you what is happening here. Fine. B was the input, so this is the inverter gate. Here what we will get? We will get B complement. This is C, so C as an input is coming here. Fine. Here B complement is coming, and these two gates means these two inputs are passed to the AND gate. So what we will get here? We will get B complement dot C. Okay. This we will get here as the output. Now this will be passed as an input here, and A is coming from there. Fine. So what final expression we would get here? We would get Y is equals to A plus B bar C. Okay. So this is the final expression that we will get here. Fine. This is the final expression that we are getting here, as I have told you just now. Y is equals to A plus B bar C. Fine. So I hope till now you must have understood all the basic concepts of the basic logic gates. Fine. Now next coming to the universal gates. Fine. next coming to the universal gate. So in the universal gate, first I will be telling you about the NAND gate. Okay, so here I have told you basically about the two input NAND gate. Basic symbol is a D with a circle. The basic symbol of the AND gate was just a second. Basic symbol for the AND gate was it was this. Fine. So for the NAND gate, what is happening here? For the NAND gate, what is happening here? That this means output of this AND gate is passed through inverter, and we are getting the final output of the NAND gate here. Fine. Output of the NAND gate we are getting here. Okay. So this is basically the simplified logic symbol of the NAND gate, a D and a circle. This represents the inverter operation, or you can say this is the basic symbol of the NAND gate. Fine. Now, what would be the expression? So, the expression would be, expression of the AND gate was, the basic expression of the AND gate was Y is equals to A dot B. This was the expression of the AND gate. Fine. This was the expression of the AND gate. Okay. So what this NAND gate is doing, this NAND gate is basically inverting this output. So what would be the expression of this NAND gate? It would be A dot B ka bar. Okay. So this is the basic expression of the NAND gate. Okay. It is also written here. This is the basic expression of the NAND gate. Fine. Now here in this case, two inputs are given. So totally means total 4 combinations would be possible. All the 4 combinations are available here. Okay, all the 4 combinations are available here. Okay, now just for the understanding purpose, what I have done in this table, first I had mentioned the output of A dot B, or you can say the output of the AND gate. This is the output of the AND. This is the output of the AND gate. Right? This is the output of the AND gate. So for the AND gate, if any of the input was 0, we were getting the output as 0. Here this was 0, 0, 0, 0. Only in this case, output was 1. Fine. Now, what is the functionality of NAND gate? This is the output of the NAND gate. This is the output of the NAND gate. So, what is the basic functionality of the NAND gate? That it is inverting this output. So here we are getting 0, here we are getting 1, here 0, here 1, here 0, here 1, here 1, and here 0. So this is the basic truth table of the NAND gate. Okay. So this is the basic truth table of the NAND gate. Now, in the case of NAND, what is happening? Disable input for the NAND gate is 0. Disable input for the NAND gate is 0. How this is happening? So, what we can see that in case of the NAND gate, how this thing is working. Disable input for the NAND gate is 0. So, if any of the input is 0, and we are applying any other thing on this, this is Y, right? So let us draw the truth table. So A, 0 and 1, and for 0 it would be 0 and 0, obviously. Fine. So what we can see, if any of the input is 0 in NAND gate, if any of the input 0, what we are getting? We are getting 1 as our output. Fine. So in this case, we will get 1 as the output. In this case also, we will get 1 as the output. Fine. So disable input for NAND gate works like this. If any of the input is 0, अगर हमारा कोई भी input यहाँ पे 0 होगा, ठीक है, कोई भी input अगर हमारा यहाँ पे 0 होगा, then we would be getting 1 as our final output. Fine. So we will be getting 1 as our final output. Okay. So this was a basic for disable input for the NAND gate is 0. Fine. Now next coming to the 3 input NAND gate. Fine. So for 3 input NAND gate, symbol remains the same. Here 3 inputs are present, A, B and C, and we are getting the output as Y. Now the expression would become Y is equals to A dot B dot C ka whole complement. Fine. This is the basic of 3 input NAND gate, and as 3 inputs are present, so total 8 combinations would be available. So these are all the 8 combinations available. Fine. These are all the 8 combinations available. So as the basic functionality of the NAND gate was, if any of the input is 0, we would be getting 1 second, we would be getting 0 as our we would be getting 1 as our output, fine. So if any of the input is 0, we will be getting 1 as our output, fine. So in all these cases, at least one of the input is 0, at least one of the input is 0. Okay, so we are getting 1 as our output, fine. And here in this case, all the three inputs are 0, so we are getting 0 as our, here in this case all the inputs are 1, so we are getting 0 as our output, fine. So this is the basic functionality of the NAND gate. Okay, now next coming to the NOR gate, fine. So just like I have told you about the NAND gate, so what happens with the NOR gate? Okay, this was a symbol for the OR gate, fine. Two inputs, just suppose A and B are okay, just assume any two inputs are present here. Whatsoever we are getting the output, whatsoever output we are getting here, okay, we are passing it through a NOT gate and we are getting Y here as the output. So this is the basic output of NOR gate, fine. This is the basic output of NOR gate. This is OR gate and this is inverter, fine. This is OR gate, this is inverter, and this is the basic output of the NOR gate, fine. So this is the basic symbol and the expression would be Y is equals to A plus B ka whole complement. This is the basic expression of the NOR gate, fine. And this is the truth table. So in this truth table, total 4 combinations are present as per the 2 inputs available, fine. So just for explaining you, I have taken A plus B, the output, this is the output of the OR gate, fine. This is the output of the OR gate. So what happens here in the OR gate, if any of the input was 1, we were getting the output as 1, fine. So here this is 1, so we are getting 1. Here this is 1, we are getting output as 1. Okay, here both were 1, so we were getting output as 1. This is the basic of OR gate, fine. Now what happens in the NOR gate, fine, this would invert this output of OR gate. Okay, so where we were getting wherever we are getting 1, we would get 0, and wherever we are getting 0, we would get as 1 as our output, right? Now one more thing, that disable input for NOR gate is 1. Disable input for NOR gate is 1. How this is happening, let me explain you. So let us take a basic example of NOR gate, right? Disable input for NOR gate is 1. So if we are applying 1 and any other input A, fine. So now let us check what we will get at this output. Okay, so for A, 2 inputs 0 and 1, and for 1, 1 and 1. Okay, so as you can see in the truth table, if any of the input is 1, what we are getting? We are getting 0 as the output, fine. So here what we will get? We will get 0. Here what we will get? We will get 0. This is the basic output. So in NOR gate, disable input for the NOR gate is 1. What does this mean? This means if any of the input is 1, whatsoever other inputs we are applying, it doesn't matter, we will always get the output as 0. Okay, I guess यहाँ तक समझ में आ जाएगा. Till now everything would have been clear. Okay, now coming to the 3 inputs NOR gate, right? Now coming to the 3 input NOR gate. So here 3 inputs are, just a second. Here 3 inputs are present, okay, A, B, C, and we are getting Y as the output, and the expression would be Y is equals to A plus B plus C ka complement, fine. Okay, now as 3 inputs are present, so we will be getting total 8 combinations. The total 8 combinations of input are present here, and as I have told you just now that in NOR gate, if any of the input is 1, we will be getting 0 as our output, fine. So you can easily see that in this case only all the inputs are 0, so we are getting 1 as our output, and in rest all the other cases, so in the NOR gate, sorry, in the NOR gate, what happens if any of the input is 1, we will get 0 as the output. Fine. So in this case, all the inputs are 0, so we are getting 1 as our output. And in rest all the other cases, what is happening? Minimum one of the input is 1. So what we are getting 0 as our output. Fine. अगर कोई भी इनपुट एक हमारा 1 हो जाएगा तो हमें क्या होगा, हमें सारे के सारे आउटपुट क्या मिलेंगे, सारे के सारे आउटपुट हमें 0 मिलेंगे. फाइन. तो ये एक चीज हुई है ना. तो दिस इज द बेसिक फंक्शनैलिटी ऑफ द 3 इनपुट NOR गेट. फाइन.